Good evening, everybody. Welcome to Planets and Moons chat in the Open University's Open XR studios. I'm Dave Rothery, the chair of S283. This is an event which we run twice a year, mainly for S283 students, but we open it up to the wider OU planetary science community. With me is Nisha, who you will hear more from shortly. She's a third-year PhD student. We're here to answer your questions about planetary science. But first of all, we'll talk a little bit about the work we do and about news events which are going on. Those that were engaged in the chat earlier on, I pointed out the widgets. We're asking you where you are, but also want to know which solar system bodies you think formerly had life and where you think there might be life now. And we're asking you to suggest which were the first to put boots on the moon, USA/NASA or China. We'll look at these widgets at the very end and see what the results are. So if you've not answered those widget questions, please find time to do that. And I should point out that you might be seeing us in a tiny window on the left, top left of your screen. If you've got the chat down the right, you can go full screen on the webcast and dismiss the chat and flip to and fro, depending whether you'd rather see us and our pictures large or engage in the chat. So let's get cracking. So, Nisha, I've said you're a third-year PhD student working on Mars. What is it you're doing?
Thanks, Dave. Hi there. My project involves looking at fluvial and lacustrine processes.
That's rivers and lakes.
Yes, it's just a fancy word for rivers and lakes on Mars, using orbital imaging data. That's how I do this, using orbital imaging data. The area that I'm really interested in is Oxia Planum, and this is where the ExoMars mission will be landing.
That's the European mission to Mars.
Yeah, the European mission to Mars. That's where the Rosalind Franklin rover will be landing. And the area that I'm really interested in is just southeast of Oxia Planum. And this mission will occur in 2028. It was going to launch in 2022, but now it will be launching in 2028.
So launch in 28, and that will arrive in 2029, will it?
2030.
2030,
yeah.
Okay. And this is the area that you're working on behind us now, yeah?
Yeah, this is the area that I'm working on at the moment. So the aim of the ExoMars mission is to search for signs of life, ancient life, and water is obviously the key ingredient for this. So Oxia displays several fluvial and lake deposits, which is why I'm looking at these craters that you can see here. These craters, we think that they were a lake system in its ancient past. And the reason why looking at lakes is so important is because they serve as a good catchment for water, nutrients, and for chemical reactions to take place, which are all the key ingredients for life.
So we're looking a long time back in Mars's history.
Yeah, about 3.5, about 3.6, 3.5 billion years ago. Yeah.
So there was rainfall then?
Yeah, so there was rainfall then, sure. And then these lakes were sustained by groundwater. That's how they maintained.
So filled up by water seeping in?
Seeping in.
Okay.
Yes.
But it spilled out of some craters. I know you're going to tell us, aren't you? So
yeah, so these chain of craters show some key features that prove that these were once a lake system. So I'm just going to take you through a tour of different features that prove that these were once lakes. So the first feature, if we go to the next slide, is an outlet feature. So here we can see that the crater filled up with water and breached the rim, and you can see that outflow channel over there. And we know this is an outflow channel because we can see a sedimentary fan deposit around the channel, and we know that water flowed out and not in because there's no fluvial channels to the north of this crater. And those degraded deposits you can see on the crater floor are just rounded sort of deposits which may have just degraded as the outlet was retreating.
Okay, so I can see a scale bar there at the left. So this crater is about 15 kilometres across?
About 20 kilometres.
20. And so how deep would the lake have been? A kilometre or so?
Yeah, sure, yeah, definitely. About a kilometre.
That's a deep lake.
Yeah, definitely, yeah. If we move on to the next slide, another feature that shows that this was a chain of crater lakes. So this is a sedimentary fan, and we can see that the crater on the right filled up to the top, and then deposited water on the crater in the crater to its left, and it displayed. You can see this sedimentary fan on the crater on the left.
So water flow following the arrows from the crater on the right through the breached rim into the crater on the left.
Yeah, and this is significant because it shows that the crater on the right filled up to the top at some point in time, which is really interesting. We can
and so the water flowing in was obviously eroding stuff away from the breached rim, and that got deposited on the floor of the next crater.
Yeah, so you can see on the crater on the left that there's been some sort of deposition on the crater floor. You can see these like hummocky sort of texture on top that's much more younger material than what's seen at the bottom.
Okay.
If we go to the next one. So in the floor of this large crater here, we can see an erosional window on the crater floor. And this is really significant because this is a high-rise image, about 30 centimeters resolution per pixel, and we can also see horizontal layers around its edges, and we think that this is caused by an lacustrine environment.
Okay, so that strange shaped feature occupying almost all the centre of that view is an irregular shaped hole in the ground that's
so we think it's
2 kilometres long.
Yeah, it's about 3 to 4. It's about 3 to 4 kilometers long and around 100 to 150 meters deep. And we think it started off as a crater and then over time got eroded into the shape it is now.
So an impact crater which would have been circular, but it's been enlarged by what, the wind scouring stuff away.
Yes, definitely.
Can't be water taking that away.
No, for sure, no.
And the layers you can see in the sides of that pit are layer after layer of washed in sediment burying the original crater floor, which has then been cleared out by the wind.
Yeah, and we also have mineral data for this. We have omega data that shows hydrated minerals within these layered deposits, which is also indicative of a lacustrine environment.
So this is a light spectrometer visible near infrared looking at absorption features attributable to hydrated minerals.
Yes, definitely.
Great. Otherwise, it would be just guesswork based on geomorphology, but there's actual data about what the minerals are.
Yeah.
It's very important to put independent lines of evidence together.
Yes, for sure. If you go to the next slide. Yeah, so those are all the key observations that prove these were lakes.
Okay, so you chose these craters as a large part of your PhD work. Now, I know you got to name these. These were not named, were they, beforehand? So tell us a bit about giving them some names.
Yeah, if we...
There are rules, aren't there? You can't just choose any old name.
Yeah, sure. So if we go to the next slide. So these are the names I've given the craters. So we have Abu, Varahamihira, Arna and Kiara. So as you know, the International Astronomical Union give names to different planetary features.
They're in charge, aren't they?
Yeah, in the solar system. So the criteria for naming craters on Mars, so if craters are larger than 50 kilometers, they have to be named after scientists who've contributed to Mars research in some way.
So that's Varahamihira.
Varahamihira.
Thank you.
So Varahamihira was an ancient Indian astronomer from around the time 500 CE, and he wrote an encyclopedia called Brihat Samhita, which is just basically a catalogue of different scientific observations that he took at the time. And these included things like planetary motions, eclipses, just anything in general, like rainfall patterns and cloud movements. So I decided to name the crater after him.
That's very appropriate. What about the other names, Abu and so on?
Sure. So if we look at the other 3 craters, they're smaller than 50 kilometers. So the IAU have a different criteria for naming craters under 50 kilometers. So these have to be named after rural villages. So I decided to pick a rural villages in Rajasthan, India. So I've named it Abu, Arna and Kiara. And I've named it Abu because when I was 10 years old, I went on holiday with my family. If you go to Mount Abu, you see loads of lakes there, man-made lakes. And that's something that always just stuck to me. So I decided to name it Abu. And Arna and Kiara are towns near Abu.
Have you told the people living in Abu and Arna and Kiara that they have craters on Mars?
No, I haven't, but I will one day, and I'm looking forward to that.
Okay, great. Thanks, Nisha.
That's okay. So, Dave, most viewers will know that you are involved in ESA's mission to Mercury. How's that going?
Well, this is Bepi Colombo.
Yeah.
It was launched in 2018, and it's had 4 flybys of Mercury already. There's 2 more to come, one in December, one in January. We've now matched orbits with Mercury. We've got the same orbital period about the Sun as Mercury. We've had each previous flyby has slowed us down a little bit, so we're now in exactly the same orbital period as Mercury, but we're not sufficiently close to Mercury all the time to get into orbit about Mercury, so that's what we're aiming to do now. The picture behind me here is a spacecraft in flight, just an artist's impression, and that blue glow at one end is the ion drive. It's solar electric propulsion. Those big side-to-side solar panels are making electricity from sunlight, ionising the xenon, which is coming out, and that's the rockets. Xenon's a very high-mass element, so it gives a lot of... You ionise xenon, it goes out electrostatically, and you've got a big impulse from that. So that's what we're using to match speeds with Mercury. I've got pictures from the most recent flyby to show you, so let's go on to those. So this is one of the views of Mercury. Now, this is not really a science picture. As you'll see in the last slide I've got, the science instruments can't see the planet in cruise mode because we've got 2 spacecraft stacked together plus the propulsion unit. But we have got monitoring cameras on the propulsion unit, and this is looking down at Mercury as we whiz by. There's a couple of spacecraft antennae in the foreground. So here's a view of Mercury, and let's just step forward. And what's come into view now from the same camera is a peak ring basin. Large craters on Mercury don't just have a central peak, they have a ring of peaks called peak ring basins. This one's called Vivaldi. It was named in the 70s when the first spacecraft passed Mercury. Mariner 10 saw part of it illuminated by the sun, named after a composer. Craters on Mercury named after artists, musicians, painters, singers, and so on. So people will have heard of Vivaldi, an Italian composer. And as we carried on, a new crater came into view. You can see Vivaldi's right near the limb at the bottom. In between the 2 antennae, there's a crater which we newly named. We're going to see that in a little while. And the final view from this camera is a view looking down towards the South Pole, which is somewhere near the top of the globe there. We'd not seen from Bepi Colombo Mercury's South Pole before, so that was nice to see. So that ring near the top is kind of 65-degree latitude, and the South Pole's labelled there, isn't it, right on the terminator near the top. And we'll just have a look at a view from one of the other cameras. This is the closest view ever of Mercury. This was from a range of 160 kilometres above the planet. This was the closest that any spacecraft has flown past a planet previously that wasn't going to crash into it.
Yeah.
And we've flown past moons closer than this, but this is the closest flyby of a planet. And it's only possible because Mercury has almost no atmosphere anyway.
Yeah.
If you'd gone that close to the Earth or Mars, friction in the atmosphere would have put paid to you. Anyway, the closest ever view of Mercury. And as we flew away from Mercury, other things came into view. That's a crater that hadn't been named before. We knew we were going to see that crater. It had been imaged by Messenger, NASA's mission, which orbited 15 years ago.
Yeah.
So we asked for it to be named after an underrepresented group. So they named it after a female New Zealand painter. She painted lots of pictures of flowers, did Ms. Stoddard. It's another peak ring basin. And have we got another picture? I'm not sure. Okay, well, we've got a picture of a spacecraft. When we get there in December 2026. This will happen in stages. We will ditch the propulsion unit, that thing at the bottom. That's where the monitoring cameras are.
Yep.
We'll then ditch the thing at the top, which is the Japanese orbiter called MIO. We'll spin that up and it will be spin stabilised. That ring-like thing, which is a sun shield, will be thrown away. And then the bit in the middle, labelled MPO brackets ESA, that's the Mercury Planetary Orbiter that the European Space Agency owns. And when that's free of its add-on encumbrances, the science instruments on that can start studying Mercury. And there's so much we're going to learn about Mercury from that instrument package.
Yeah, excellent. So it sounds like it's all going well then with the mission.
Well, yes and no, but the spacecraft is healthy.
Mm-hmm.
This time last year, we were expecting to get into orbit in Christmas 2025, but the ion drive isn't providing quite the power we expected it to. It's degrading somehow. So it's going to take another 11 months before we can get into orbit about Mercury. So now we're aiming to be in orbit by November 2026. So 2 years from now we'll be in orbit.
Okay.
It'll take a while to commission the instruments and the real good science will start flowing round about April time, 2027.
Okay. Really interesting.
So one thing we like to do before we get on to questions, and I've seen nobody's asked us any questions yet, we do have some advanced questions. One thing we like to do is talk about recent events. Now, what's caught your attention that's been going on lately, Nisha?
What's caught my attention? So just over 3 weeks ago, NASA launched the Europa Clipper mission, and its aim was to determine whether there are places below the surface that could support life. As we know, Europa has a ice shell around, and beneath it, it has a water ocean.
Yeah.
And the aim of the mission is to map the ice shell, to understand its composition, geology, and if it has any astrobiological potential.
Yeah, these are images from Galileo, which was orbiting, crikey, 25 years ago in the Jupiter system. And those are really detailed images.
Yeah,
You've got rafts of ice with a previous texture on them that have been ripped apart. And when you get into the second book of S283, Astrobiology, Introduction to Astrobiology, there's a whole chapter about icy moons, particularly Europa, and you'll see this very image, in fact. So that's something to look forward to. But Europa Clipper is focused on Europa, isn't it?
Yes.
But is it going to orbit Europa?
So it's going to do about 50 flybys past Europa. It will be mapping loads of its surface area, but it won't be orbiting. They're just
it's orbiting Jupiter and multiple flybys at Europa. And this is the structure we think inside Europa. The view on the left is a fashionable one, isn't it?
Yeah.
There's rock at the bottom and 200 or so kilometres of water or water ice.
Yeah.
But it's probably a thin ice shell and a very deep ocean of water, and that's exciting because
it's exciting because at the base of Europa's at the base of Europa's ocean is a process called tidal heating, and that's important because it's necessary for
it's a small body, isn't it?
Yeah.
So there won't be a lot of radiogenic heat inside, but if there's tidal distortions, as there are, because Europa is orbiting Jupiter in twice the time it takes the innermost large moon Io to orbit. So there's an orbital resonance, and it distorts Io and Europa are both distorted periodically, and that's heating up the interior. And you can have water reacting with hot rock, and that's all kinds of great chemistry.
Great chemistry, yeah.
But Europa Clipper's exciting because we have friends who are working with us whose
we do.
career depends on this spacecraft being
sure.
successful. We've got some video we can show of the excitement in the room when it was launched. So as people holding their breath as this rocket's about to take off, it was quite a day. I remember watching the launch of Mars Express, which took Beagle 2 to Mars, and when that took off, the glare from the rocket engines oversaturated the cameras and the whole picture went white and we thought it had blown up. But It didn't. But this was a flawless launch. That was great
How
to see.
nervous everyone is.
Yeah. Now it's in space. It's on its way to Jupiter.
Yeah.
It's been checked out. All instruments are working.
Yeah, sure.
It's just a long cruise until it gets to Jupiter, isn't it?
And it will reach Europa in 2030. So the spacecraft would use gravity assist from Mars in 2025, and then another one from Earth in 2026, and then we'll reach Europa by 2030.
Well, it's still a shorter cruise than Bepi Colombo had to get to Mercury. It's a longer distance.
Yes,
but
for sure.
The sun's gravity is going to help slow it down when it
Yeah.
gets there, whereas going to Mercury, you get faster and faster as you get in. It's really hard to slow down.
Sure.
So what are we going to do next? Oh, yeah, it's time we did some questions, isn't it? So what have we got?
So...
Oh, I know. I should just point out that when you get into the latter part of S283, there's videos about Europa Clipper. I shot videos in 2015 and 2017, and indeed this year with scientists who are involved in planning the Europa Clipper mission. So on the S283 web pages in the calendar, you'll find links to this video from 2015, and then we've got a 2017 one, and then just a few months ago I spoke to Brittany Schmidt, who's the lead author of a paper that you will be reading for TMA 04. So that was good to have her speaking to you about what Europa Clipper is going to do. Okay, now we go on to the
should we answer
questions.
some questions?
Let's answer some questions, and we'll look out for live questions as well, which we still don't have.
Two S283 students have been asking about planetary collisions. Mike Beard has asked whether planetary collisions have ever happened or could ever happen in our solar system, and mentions a YouTube video that he saw about a collision involving Neptune and Pluto.
Yeah, well, I don't know what YouTube video you saw, Mike, but planetary collisions, yes, in the distant past, when you reach the origin of the solar system, towards the end of introduction to the solar system, you'll learn about planetary embryos bumping into each other. So these are bodies about a tenth the size of the current planets, or the current terrestrial planets. And planets did grow by collision. Some collisions just shatter things and they fall apart. It's the collisions where things merge that allows bodies to grow. And they don't bounce off each other. They either shatter each other or one melts the other and they merge. So collisions were going on at the time of planetary growth, but we're not getting collisions between like-sized objects in the current era.
Yeah.
Neptune and Pluto, though, that Mike mentions in the YouTube video, I wonder if, Mike, you've seen a hypothesis for how Neptune gained its moon, Triton. Triton, the largest moon of Neptune, is orbiting the wrong way around Neptune. It's what we call retrograde. And it's possible that Pluto and Triton were a double body that passed close to Neptune, and one body got captured by Neptune into this reverse retrograde orbit, and the other body escaped. It's very hard to capture a single body. If you've got a double body, you can capture half of it, and everyone can carry away the angular momentum.
Yeah.
So it wasn't a collision, it was a close encounter. But that story is kind of hard to sustain, because what we've got left in Pluto is itself a double body. We've got Pluto and its very large moon, Charon. So we're not really sure.
Yeah.
But there may have been a close encounter between perhaps the other half of the Triton double body is something we can no longer see. It may have escaped the solar system altogether. But that could be a collision. But we're talking about 4.5 billion years ago.
Yeah. So on the same topic, Simon Chapman says back in the olden days, Velikovsky was quite popular. I'm guessing he was discredited because now I'm not seeing any reference to his ideas.
Yeah, when I was a lad going to the public library trying to find books on astronomy, the books by this chap, Immanuel Velikovsky, were on the shelves, hardbacks in those days.
Yeah.
He's very much discredited, Simon. He was writing it in the 50s. He was looking at biblical and other mythological or legendary accounts of what went on, and some sort of serious astronomical records, but probably corrupted, suggesting that Mars and Venus had collided close to the Earth, and that Venus used to be a comet, and attributing all kinds of ancient legends to horrendous astronomical events.
Yeah.
But certainly, Mars and Venus have been in their present orbits for billions of years. There is chaos in the solar system on a long term, but we haven't had planets bumping into each other. The collision of Mars and Venus at the time of the Trojan War was completely discredited. Absolute rubbish. I mean, you could see the traces of that on Mars. Mars has got plenty of impacts, but if you crash Mars into Venus, they're going to melt each other because of the kinetic energy and it's so no. Things in books by Velikovsky are very much discredited, Simon. But it's curious because in those days we weren't talking about planetary growth by collision. It was just large bodies soaking up smaller bodies. So we did have like on like collisions, we think, but 4.5 billion years ago, not in the past 10,000 years, which Velikovsky was claiming.
We actually have a couple of questions, live questions.
Oh, great.
So Kyle Page asks, what is the likelihood of Planet 9 being discovered in the near future?
Okay. Well, we do know that Pluto isn't Planet 9. It used to be the 9th planet, but there are lots of bodies which have got, the biggest one's got slightly more mass than Pluto, ranging downwards indefinitely in what we now call the Kuiper belt. So Pluto is one of the closest, one of the largest bodies in the Kuiper belt. And Pluto was ruled out from being a planet. You've probably read this already, I hope so. It's in chapter 1 of Introduction to the Solar System. It wasn't sustainable, said the IAU, to keep calling Pluto a planet. They've invented this class of bodies called dwarf planets, but the whole Kuiper belt is really bodies which never grew into large planets. So is there a Planet 9? Is there something we would call a planet? To be called a planet by the when was it, 2004, 2006, the IAU had its ruling, 20-year-old rule now. To be a planet, you have to have cleared your orbital neighbourhood. That means your orbit, nothing crosses your orbit that's of comparable mass to you. You've got to be orders of magnitude less massive. So you've got to go a long way out through the Kuiper belt till you get to a region of space which is devoid of objects of kind of planetary size. And if there's one object out there dominating that, we would call it a planet. I think most people are suggesting there isn't a large body out there now. But the question is, what's the likelihood of it? I wouldn't bet on it unless it was really, really favourable odds. But, there's a lot we're learning. What else have we got here? Simon Chapman says he remembers Velikovsky trying to account for the retrograde motion of Neptune. Neptune doesn't move in a retrograde fashion, Simon. Neptune goes round the sun in the same direction as the other planets, and its rotation is prograde. You may be talking about the retrograde motion of its large moon, Triton. Velikovsky tried to account for a lot of things. He was saying Venus's atmosphere is full of hydrocarbons, which it patently isn't. He's completely discredited. Oh, there's a Mars question come in. I'll give you that one, Nisha, before we move on to the ones we had in advance. Is it more likely there is evidence of life under polar caps on Mars, says Paul Hawkins?
Could be. So obviously polar caps is where we find water. We know that there's water there, and water is a key ingredient for life. What would you say, Dave?
Life under the polar caps? Well, what's the energy source? You've got to have some chemical gradient to take advantage of. So we talked about the hydrothermal life on the floor of Europa. You don't need sunlight, you just need a chemical gradient. It would be less energy for life under the polar caps of Mars than there would be in the ocean of Europa, because we think there's tidal heat there. Polar caps of Mars, cold, not much chemistry going on. But it's feasible. The thing is, if Mars once had conditions suitable for life, it's kind of well, it did have conditions suitable for life. We're pretty sure about, but did life ever develop there? That's the unknown question.
Yeah.
If life ever got started,
Yeah.
it's probably clinging on somewhere. So there
Yeah,
could be
for
some
sure.
under the polar caps, couldn't there? But
Yeah.
it's easier to find traces of past life at the surface in places like Oxyplanum,
Yeah,
where
for sure.
Rosalind Franklin rover's going to be going.
Yeah, for
Yeah.
sure. Yeah. Leads on perfectly to the next question.
Well, we'll come to that, but somebody's asking, Julia Paoletta is saying, what are your thoughts on potentially populating Mars one day? Now, Elon Musk has come into quite a lot of power in the past day or two.
So it might be
He's
having
got the big
sooner.
rockets.
Yeah, for sure. So what are my thoughts on potentially populating Mars one day? So I do think it will happen for sure. As they've said, Elon Musk is planning on going there. I think there's a lot of technological development that needs to occur before we go there. I think that there's a lot of things that we need to be able to sustainably live there. There's no point of going all the way to Mars and then not being able to survive. So we need to make sure that when we go there, we stay there for a long.
I lent you a book by Robert Zubrin,
Yes, you did.
who reckons we could make money out of going to Mars if we send 50 rockets a year there.
Yeah, for sure. So he's hoping that over time the cost of traveling to Mars will decrease, like the same way flights, plane flights. The price of plane flights happened. So they were really expensive once, and now they're much more affordable for people. So they're hoping the same thing will happen with trips to Mars.
There are scientific and ethical considerations
For sure.
which ought to give pause for thought. As you'll read about in Introduction to Astrobiology, the COSPAR, this Committee on Space Research, it's an international umbrella organisation, has rules about planetary protection, which say you mustn't go anywhere that is capable of hosting life if you're taking microbes from Earth there, because you'll contaminate that environment.
Yeah.
There's ethical considerations, should you take life from one planet to another and let it run riot.
Yeah.
There's also scientific consideration. If we want to understand if life ever got going on Mars, we'll spoil the story if we take our own life there.
For sure.
And muddle up the signal. So humans on Mars, as soon as you drop a plastic bag full of feces into the ground, you've contaminated the environment.
Yeah.
So probably people are just going to ride roughshod over those rules. It's going to be like the Wild West, potentially. But these are issues which should be being considered. So that we could have people on Mars soon, but they'd be breaking all kinds of rules. But we'll see what happens. So but there's a question we had in advance. Zach O'Neill sent one in. He says, given what's been in the news recently concerning the discovery of life within billions-of-year-old rocks on Earth, does this support the hypothesis that life could still be present on Mars in a similar environment that got in there from a time when Mars was warmer and wetter?
So for those who haven't heard, scientists have found living microbes inside a 2 billion year old rock. So they excavated a 30 centimeter core from the Bushveld Igneous Complex, and this is from South Africa.
30 meters deep.
Yeah,
wasn't it?
15 meters deep.
15, okay.
15 meters
quite
deep.
Shallow.
So this Bushveld complex is located in South Africa, and they discovered microbial cells living in the rock fractures. So Zach, the answer to your question, yes, definitely, because the rocks that they found these microbes in are similar ages to those on Mars, so around 2 billion years old. So life could still be present. NASA's Mars rover Perseverance is currently due to bring back rocks that are similar age. So that's something we're looking forward to in the future. And another reason why this discovery is so important, because it also sheds light on where we should be looking for life. So these rocks are 2 billion years old. So that's Amazonian age. Amazonian age is around 2 billion
Okay.
2 billion, 2
Mars's
billion years.
timeline is
Mars
divided into
timeline.
Milwaukeean, Hesperian, Amazonian. The
Yeah.
Amazonian began 3 billion years ago
Yeah.
on Mars.
So
It's in book 2 of S283.
So maybe we should look at we should be looking at those types of rocks, and it also makes us question whether we should be looking deeper for life, because we've just been looking at the subsurface so far, and these rocks were found 15 meters deep. So maybe we should be looking deeper.
I'm sceptical. I mean, okay, but
Yeah.
this rock core, the rock is 2 billion years old,
Yeah,
and they've
for
got
sure.
these fractures filled with clay,
Yes.
which have microbes in.
Yeah.
They've got no proof that the microbes have been there for 2 billion
Yes.
years. They could have been flushed in 100 years ago,
Yeah.
as far as I can see.
For sure.
I'm very sceptical about
Yeah,
this paper.
more studies definitely need to be done on how old these microbes are, because they could have colonized recently into this rock. But yeah, thank you for your
Yeah.
question.
But I have been more live questions.
Oh, okay.
Could Earth, Venus and Mars have had microscopic life which came from the same source, asked Paul Wilkin. Yes, potentially. We have meteorites on Earth which have come from Mars. We're certain of that.
Yeah.
They match Martian chemistry. We've got samples of trapped Martian atmosphere in them. An impact of a large body onto Mars throws out ejecta, most of which falls back on Mars. Some gets away into space, and a small fraction of that ends up on the Earth. So there have been rocks taken from Mars to Earth. Could have gone the other way. Earth experiences impacts.
Yeah.
It's harder to get ejecta off Earth into space, but it can happen, and some of
Yeah.
that could find its way to Mars. So Earth and Mars have been exchanging bodily fluids for the past 4.5 billion years. We don't know that life on Earth began on Earth. It could have begun on Mars.
Yeah.
So if we do find life on Mars, an important thing to discover is whether Earth and Mars life are related,
Yeah,
or did they have
sure.
independent genesis?
Yes.
And likewise, rocks from Venus. Yeah, Venus today has quite a young surface. There's not any ancient material on Venus as far as we can tell. It's probably all less than 1 billion or 2 billion years. There's been a
Yeah.
lot of resurfacing on Venus.
Yeah.
So the record on Venus of its deep past has gone. But 4 billion years ago, when there were more impacts going on, there could have been rocks from Venus flying to Earth, and from Earth to Venus, and from Mars to Venus. So yes, the life on those 3 terrestrial planets, if it ever existed on the other 2, could have just had one genesis, which is why finding life on Europa would be so exciting. It's much harder to get life from the terrestrial planets out to the Jupiter system.
Yeah.
If we find life under the ice on Europa, it's much more likely to have originated there independently of life in the Earth-Mars system.
Sure.
So, I mean, it's a big unknown question. There are lots of niches where life could survive.
Yeah.
Not many where life could be flourishing. Nowhere where it could be flourishing like on the Earth, but certainly places where life could scratch a living at the microbial level.
Yeah.
But did it get going in those places? That's the big unknown question.
Yeah, for sure.
Okay, let's go to the advanced questions.
So Dave, here's a question from Jaime Fernandez. And so following the discussion in the forum on Mercury's eccentric orbit compared with other planets in the solar system, could you please comment on what might be the reasons for this?
Okay, I should have looked at that discussion in the forum, but Mercury does have the most eccentric orbit of all the planets. Pluto's got a more eccentric orbit, but Pluto's not a planet. Mercury at aphelion is about 0.4 of an astronomical unit from the Sun. At perihelion, it's only 0.3 AU from the Sun. So it's quite an eccentric orbit. Why it happened? Well, we don't know. It probably always had a fairly eccentric orbit. One thing about Mercury that's strange is it's enriched in volatiles. Its potassium fluorine ratio is high. That was measured by MESSENGER using gamma ray data. MESSENGER was a NASA mission which orbited Mercury 2006 to 2011 or thereabouts. It's rich in volatiles. There's lots of signs of volatile processes going on. And it's hard for a body that close to the Sun to have been born with a lot of volatiles. Maybe Mercury started out further from the Sun than it is now, came and had a close encounter with the Earth or Venus, or maybe was a hit-and-run impactor onto the Earth or Venus.
Yeah.
If it hit the Earth, it was before the Moon formed. So it came in from further out and then was left in a eccentric orbit around the Sun. It's now become stable. This orbit that Mercury has around the Sun, let's get it right, it spins on its axis 3 times for every 2 orbits it does around the Sun. And that means sunrise to sunrise is actually 2 Mercury years. It's in a 3-to-2 spin-orbit coupling. And that is a stable situation tidally, because it's got tidal bulges facing, well, that face the Sun all the way through perihelion when its rotational speed almost matches its orbital speed, then it lags behind. So it's tidally captured. So it's a stable, long-term, stable 3-to-2 spin-orbit coupling. So we think it's probably had that for a long time, probably since it came in from further from the Sun into where it is now. So
adding on to this,
go on.
He also asks, what are we hoping Bepi-Colombo mission might reveal about the origins of Mercury?
Okay. Well, Jaime, I've said that Mercury is rich in volatiles. We've measured the high potassium thorium ratio. We know there's a lot of sulfur there. The X-ray spectrometer that Messenger had found sulfur. We know there's quite a bit of chlorine there. We don't know the other volatiles. When Bepi-Colombo gets there, it has a very good X-ray spectrometer, British built, led by Leicester University. I'm a co-investigator on it. That will measure a dozen to 15 of the most abundant elements on Mercury. The Sun's X-rays illuminate the surface, and that causes X-ray fluorescence. So the solar X-ray photon comes in, knocks an electron off away from the nucleus, and other electrons drop down to fill the vacancy, emitting X-rays as they do that. That's X-ray fluorescence. And the energy of each fluorescent X-ray is very characteristic of each element. So we'll get what elements are there, we'll get their abundances across the whole globe. More elements and in much greater detail than Messenger did. We've got other instruments on board. And we know now there are places on Mercury where the surface is dissipating away to space. It's obviously the loss of volatiles, but we don't know what's allowing the volatiles to escape. Is it heat from the Sun? Is it solar photons breaking chemical bonds? Is it micrometeorites breaking bonds? We really don't know. And we don't know what volatile elements or compounds are there. We've also had a long history of explosive volcanic activity. We can see holes in the ground ripped out by explosive eruptions, which have occurred on the same spot multiple times in some cases, throwing out material across a range of maybe 100 kilometres. So quite violent eruptions, excavating large volumes of material over time. And you only get explosive eruptions if you've got something that can turn to gas. It's no good just having hot rock welling up to the surface. It will just ooze out in lava flows, which happened a lot in Mercury's deep past as well. But the more recent activity has been dominated by explosive eruptions. So we've got gas coming out of the planet still, maybe into the past billion years of time.
Yeah.
So we've got volatiles, and we don't know what volatiles are driving explosive eruptions. We hope to find traces of that when we map Mercury. But there's a lot about Mercury that we're going to find out from Bepi-Colombo. Fault activity as well. It's a great place for geologists. And the magnetic field as well. It's got a molten core, magnetic field, solar substorms. We've got 2 spacecraft orbiting Mercury, Bepi-Colombo and MIO, the Japanese one. They've both got magnetometers on. We'll see the magnetic field simultaneously in 2 different places. That's never been done anywhere on any planet other than the Earth before. We're going to learn so much from Bepi-Colombo. So watch this space. Have we got any more live? We've got loads of live questions here.
Well, we have an interesting one from Lucas.
Go on then.
So how confident are you that ESA will finally manage to successfully land on Mars? And what lessons have we learned and implemented from Schiaparelli's failure?
Okay, Schiaparelli was an engineering test for landing on Mars.
Yeah.
Our head of department had an experiment on board.
Oh, really?
Yeah, he did. Yeah, nobody can ever be confident about landing on Mars.
Yeah.
The Rosalind Franklin rover for ExoMars should have been there already, but the launch never happened because Russia invaded Ukraine, and the landing system was Russia. It's going to be launched from Russia as well, Kazakhstan. So the whole large parts of that mission have been redesigned.
Yeah. It was also supposed to launch before COVID, but then that didn't happen. And I think that the fact that we've landed Perseverance, we've also learned lessons from the Perseverance rover landing. So that's also helpful.
Yeah. And we have friends. Well, you'll be hoping to make a career out of Rosalind Franklin, won't you, after your PhD? There's a lot of people's jobs riding on this.
Yeah, definitely a lot of people's jobs. We hope it gets sent, actually. We've been waiting a long time.
We have. How many more questions have we got time for? Peter Lewis, the Goldilocks zone has been defined in our solar system. What's your thoughts on the Goldilocks zones around planetary systems that are relatively close to ours in the search for life? Okay, Goldilocks zone is the idea that it's an idea from a time when the only life people are really thinking of is Earth-like life, so surface life, where the surface is not too cold but all the water's frozen, not too hot but all the water boils away to space. So you need to be not too close to the sun like Venus is today, and not too far from the sun or your star, probably like Mars is today. But Mars is just inside the Goldilocks zone. But any further out and be no hope for life. But the Goldilocks zone doesn't apply if you think about life below the surface on somewhere that depends on tidal heat, like Europa.
Yeah.
But the Goldilocks zones around planetary systems relatively close to ours in the we do know now that most stars have planets.
Yes.
And a fair proportion of those stars with planets have planets that would be in the Goldilocks zone. Probably many more of them have Europa-like bodies orbiting giant planets. So we've doubled the chances for there to be life. So the big unknown question is, if conditions are suitable for life, will life get started there? And we don't know how likely it is that life gets started. Until we find life in one other place than the Earth, which we can confidently say formed independently of life on Earth, we won't know. But if we ever find proof of life anywhere that's unrelated to us, it'll be extremely likely that there's life all over the galaxy.
Yeah, I would be surprised if we were alone.
Yeah, well, either way you look at it, it's a frightening answer.
Yes, it is, for sure.
Go on, let's do that one from Mike.
Yeah, sure. So we had another question in advance from Mike Beard. So he asked, regarding the Great Red Spot on Jupiter, which we all know to be a continuous, long-lasting storm, is the Great Dark Spot of Neptune also a storm, or is it a completely different phenomenon?
Well, both really, Mike. We've got a picture of the Great Dark Spot of Neptune seen in 1986 when Voyager 2 flew by. And it is a storm. It's a rotating storm system. Why it's dark and blue rather than red, as the Jupiter example is, we don't know. The Jupiter red spot's been there certainly for 300 years, possibly for 400 years. It's sometimes been more prominent, sometimes less, but it's always been there throughout the whole time people have had decent telescopes. A great dark spot on Neptune has disappeared, but there's another dark spot that has appeared. Now, since we don't know when Neptune first had its great dark spot, we don't know how long it lasted before it disappeared, but it has now gone and been replaced by another spot. Okay. I think we may have lost the pictures, but the Neptune's great dark spot, as far as we can tell, not long lasting. Jupiter's great red spot, still very. It has shrunk over the past decade, but it's still there. So these planets which have fairly fast rotation, they're much bigger than the Earth. There's a lot of sort of vorticity in the atmosphere. So when storm systems start, there we go. That's a Voyager 2 view of Neptune's great dark spot. There's a little dark spot just below my knee there. There we go. So, and here it is from the Hubble Space Telescope in 2016. There's an arrow pointing. It's two different wavelengths of light, but there's a dark spot of a bright cloud above it, and we can advance it and see it a couple of years. We can't. We just got these two. Okay. But anyway, it's come and it's gone. Okay, we're running out of time. Give me one more question. I've just lost it off my...
Yeah, sure. So Susanna asks a bit of an abstract question, I guess, but I've always wondered if we do discover elementary life forms on Europa or anywhere else at the matter, what would our next step actually be? Would we attempt to interact with it for research? What's your perspective on this?
Okay, well, Susanna, you're obviously realising that we're looking at elementary life. We're thinking of microbes, basically. There's not a lot of energy to power a big ecosystem, but if you've got microbes, you could have shrimp-like things grazing off them. Who knows? It happens on Earth's deep ocean.
Yeah.
So interacting with it, it's going to be no kind of social interaction. We're talking about very, very basic life forms.
Yeah.
I've mentioned the COSPAR planetary protection rules, which say that you should not contaminate any other ecosystem. I mean, the idea of carrying plague from one world to another is pretty ridiculous, really. Why should microbes from Earth be pre-adapted to attack and kill microbes on Europa, or indeed vice versa?
Yeah.
But certainly you'd be confounding the ecosystem. And we know how invasive species don't work out too well on Earth. But we would want to study life somewhere else. It's a very important question.
Yeah.
If we find life on Europa, can we do it? Is it based on DNA?
Yeah.
If it is, it's a molecular does the molecular phylogeny map onto Earth's at all? Have we got a common origin? I said it's unlikely, but we need to rule that out. Because the big question is, can you start life in two places independently? So we're going to want to study life from Europa or life from Enceladus. It might be easier to find life at Enceladus if it's jetted out into space with those wonderful plumes that Enceladus has, which you'll read about in Introduction to Astrobiology. So, yeah, I think we should study it, don't you?
Yeah, for sure. It's definitely important. We have another question.
I said that was the last one, but go on, make it quick.
Oh, okay. So are the events of the film/book The Martian purely science fiction at the moment? I can answer this. So there are some scenes from The Martian which actually will be true in the future. So, for example, the way he grew potatoes and the food he ate from packets, things like that is something that we would definitely have to do. The way we do agriculture will have to be completely different.
And he was digging up the feces bags from the departed crew members and fertilising the soil with those to give himself a good crop. Well, it's recycling. It's a closed-loop ecosystem. Sure. Is that what we do? Yeah,
I mean, we know. So there's actually Mars analog missions that on Earth here that study these things. So the MDRS station in Utah actually study things like this. Yeah.
Okay. Well, thanks for that question. We do need to wrap up now, but we'll have a look at the widgets first of all and see how many people have answered questions. First of all, where are you all from? 5 in mainland Europe, I guess that is, and we've got several dots over the UK, somebody in Glasgow, 1 in Africa or Middle East, 1 in North America. Well, welcome everybody, and thank you for joining us. And what about the answers to these questions? We asked you, which solar system bodies do you think had life in the past? So Europa and Mars look like the most popular.
Yeah.
Enceladus, Titan, Moon?
Moon.
Io? That's a volcanically active moon of Jupiter, no water, lots of radiation. But yeah, okay, the obvious candidates, I think, are there, aren't they?
Yeah, for sure.
But that's life in the past. The other question is about life today, isn't it? Of course, we don't know what I was like in the past. Yeah, we know there was life today on Earth. So we'll rule that one out. So Europa's the winner there, it seems to me.
Sure.
And Enceladus, whoever you spell it, that would be bigger if everybody spelt it the right way. I think Europa must have been misspelt somewhere. It appears twice. Anyway, yeah. Thank you for those. That's the usual suspects, basically. And who's going to win the race to put boots back on the moon? Ooh. That's narrow. 11 have said USA come NASA, and 9 have said China. What do you think, Nisha?
Well, China have been doing really well. They've launched orbiters recently, which have been doing really well. It's tough, quite tough. They've
done a wonderful job bringing back a sample from the far side.
Yes, for sure, yeah.
Okay. Thank you, everybody, for participating. It's a wonderful run of questions. I think we got to most of them. We'll have another Planets and Moons chat again in March on a date yet to be decided, and you'll hear about it in the same way that you heard about this one. Thank you very much, Ben and Jeff, for working so hard in the background to bring this event to you. And that's all. Good night.
Good night.